Hello, and welcome to the Argyle AI Solutions Expo, where cutting-edge AI tools meet real-world solutions. My name is Michael with Argyle, and it's great to have everyone joining us today. I have some important information to share with you, and then we'll turn the floor over to our esteemed opening keynote speaker. First, we'd like to take a moment to thank today's sponsor, Newbird AI. Our sponsors are committed to providing you with valuable content and a great overall experience. At any time during today's event, you can visit their virtual booths from the main agenda page, which include complimentary materials, information, and meet and greet opportunities. We also welcome you to stay socially connected during today's event. For those of you who are active on social media, please use the hashtag ArgyleDigital and follow us on X at Argyle Exec Forum. Also, be sure to subscribe to Argyle on YouTube for exclusive access to all our past events. Finally, and most importantly, we want to hear from you. So during each session, we encourage you to submit your questions and comments in the Q&A box on your screen. Following each presentation, we've set aside time for our speakers to weigh in on your questions. Thank you again for joining us today. Now let's get started. And without further delay, I'd like to introduce our speaker, Aswini Atabuti, Distinguished AI Architect with Walmart Global Tech. We're excited to have Aswini for his opening keynote presentation titled Beyond the Hype, Choosing the Right AI Tools to Power Real Business Outcomes. Aswini, thank you so much for being here today with us. Thank you, welcome, and over to you.
Thank you, Michael. I hope my audio is okay. So, thank you, Michael. Before starting my presentations, I wanted to give a quick intro about myself. I'm Ashwini. I'm currently working as a distinguished architect at Walmart since last 9 years. So, I have been part of so many mission critical teams at Walmart on the last mile spark delivery, merchant side on the merchant supplier center, as well as on the customer side for the glass platform. So before that, I have been part of many critical applications in the insurance domain, finance, healthcare, and telecom, as well as retail industry. So in my today's presentations, I'll be talking more towards like now how the shift is happening from the traditional way we saw towards AI powered, specifically now with agentic AI and going towards more of a kernel driven and towards agentic AI. So in a traditional retail, when we started to think about it, was always been reactive. So people used to go go to let's say Walmart app or any other application to do the search, click, cart, and checkout, and that's a kind of traditional funnel everyone used to play together. But it was very much kind of hateful and cumbersome, and you have to keep on repeatedly doing the same things again and again. Now with AI specifically, the way it started with Gen AI and moving towards agentic, now like we are like also focusing more towards kernel development. We wanted to see how can we make it less frictionless, and we don't have to do repetitions when we talk about like delivering the grocery items for the frozen and non-frozen items, and don't do the guesswork. Let AI do everything for you and add all the items to your shopping cart and deliver for you. So that's where like now we talk about agentic commerce, and this is something the vision of a company like Walmart and many retail industries. So when we talk about the future of retail, specifically like global behemoth like Walmart, our scales are like massive. So when you talk about how many number of people who shop for Walmart, so we have 55 million weekly shopper, and it's keep on expanding. And we have 10,000 stores which has been connected across 19 different countries. So we have a lot of global partners across India, across UK, Canada, and all. So when we talk about the amount of associates who has been working for us, it's more than 2.1 million. So anytime we have to make any small changes, it makes huge impact. And let's say our agents, when they are making any kind of mistakes, it will also cost us more. So when we wanted to deploy any kind of solution to our production, so that should be like rock solid and bulletproof to ensure that those has been like making us good revenue and saving money for the customers and optimize the workload. So, what future of our commerce? So, specifically, when you talk about the systems like Walmart, we always have been following the traditional approach of modular. So, basically, our components are like more of building from the something like building from the Lego blocks, where you can have all these components as a plug and play. Let's say you have search, you have purchase history, you have ordering systems, and you have like card. So these systems we have made it more of a modular where you can create your like own product and try it out, and if something works well, then you can keep on changing in the future. So that way it becomes more adaptive and more of a modular, and it also help you to use the best of the build component as you're trying to see in terms of the market movement. And this helps us to like cope with the pace it's happening in the AI industries, and help the customers to choose the right platforms what they're requiring. So when we started putting our like Mac architecture, so our when we put together for the composable commerce, so composable commerce has a principle called Mac architecture, and now Mac Foundation has been tending towards Mac agentic architecture. So Mac talks about how we create more of services modular. The services should be scalable and independent component. So in terms of Mac Foundations, it follows microservices. It should be API driven, cloud native, and headless. And the composable commerce should be seamlessly integrated and more personalized for the customer's needs. So we talk about we talk a little bit about the composable commerce and Mac architecture. Now let's dive a little bit into the AI before we go towards the Gen AI. So the first thing is that everyone is talking about a foundational model, creating creating their own model, trying to use the enterprise versions model from OpenAI, Claude, and Claude and Gemini and everyone. So from Walmart sites, we have created our own foundational model, which is called as Wallaby. So this is a large language model that has been tailored for retail industries. So it has been designed with proprietary training with decades of Walmart's data. So and we have also like the largest stores across the industries for the retail. And so using the data, we try to see how can we respond in a more of natural communication and help customers instead of like they are going to add the items into the cart. How can we, our Sparky will be helping them out to add those items automatically to the cart. And right now, so Wallaby has been deployed towards customer-facing application, and we are trying to finalize it across merchants, suppliers, and other domains. So one of the quick things I wanted to give on the agentic power search experience before we head towards the agentic AI. So in a traditional approach, so used to go like the customers was allowed like hey you go and look for one single items, but now with the new AI power tools about Walmart, what we have created more of a bundle where you can go and ask like hey I wanted to watch a football or watch party. So instead of individual search items like chips, wings, and drinks, you can get everything. And you can also more of intuitive queries where you can ask like hey what does my fifth grader needs for the school, and you can receive a comprehensive result from entire items what is needed for back to school programs, and these are more of personalized ones. So now let's talk a little bit about the super agents, which has been powering the retail ecosystems. As Walmart has been putting tons of money into developing the super agents, so we wanted to make it more generic across 5,000 teams in Walmart. So we have developed actually 4 super agents, but the critical ones are 3. So Sparky, Marty, and YB. So these are our super agents. So Sparky is more towards the customer end. Marty is towards advertisement, and YB is increasing our developer productivity. So we wanted to make sure that not only on the customer sides, we also wanted to ensure that what is exactly powering the customers, all the backend code, everything's how can we write and ensure that 60 to 70% of the code and going towards 80% of the code can be automated using YB. So that's the kind of whole thought process behind creating this super agent. And when we talk about when we talk about Marty, So previously, for the 3PL and 1PL advertisement, and even the third-party suppliers was supplying the data, so it was very awkward, like for them to go and create 10-pager forms to like onboard to Walmart platforms. Now with a click of one or two, so they can get onboarded and they can start advertisement on our platforms, and they can also onboard to sell their product. So now quickly, let's talk about the evolution of retail agentic architecture. 5 years ago, I would say we started about like investing on the Gen AI, and when Gen AI was pretty much into play, agentic came into picture the next couple of years, and 3 or 4 years ago, we started like experimenting on the solo agent. So specifically, when it's needed towards, let's say, we wanted to like give a communication about the purchase history for sending a notification, or like you are going for return, like we wanted to send a QR code for the returns. That's where we started like putting single agents which can handle like one specific task, and it has very limited context and capabilities. And as we are seeing more demand happen for the agentic architecture, and we wanted to automate so almost all the process at Walmart, and that's where like we started with more of reflective agents. So there, like we can at least try to use some of the APIs with not exposing all sensitive data, and only control tools with more of a specific constraint of autonomy. And that's where like reflect agents becomes very popular for us 2 3 years ago. And now we started focusing more of the collaborative agents, because Walmart's ecosystems is very complex. So you might be seeing about like I go to Walmart.com to buy some app, and buy some product, and add to the cart, and I was able to check out. That's kind of a tip of the iceberg, but what underlying under the hood happens, it's pretty complex. So all the way from supplier, the items come towards the DCs and stores, and from the DCs, all this product going towards the store using the transportations for the last mile delivery, and using the customers using those products. So that itself is a very complex workflow, which we'll be talking a little bit ahead in the slides. But it was very much complex, so that like we wanted to ensure that how can we use more of the polarity agents, where each of the agents, they can coordinate across each platforms and give more of a cohesive result. And that's why we started focusing on the collaborative agents, and we are approaching towards autonomous agents. We are not there. I think not only us, many of the industry leaders, they're also trying to thinking about the autonomous agent, and so do HEI, but we have not gone there. So right now we are focusing on the collaborative agents. So one of the key things what has come to the market is universal commerce protocol. I would say like this came like over a year, and Google is also investing so much on this one. So when you talk about like agentic shopping, so that's where like our main focus is currently. So we are focusing heavily on the universal commerce protocol. So this is open source. It's AI sync protocols where it can help us out. So first thing is that creating shopping graph. So in the shopping graph, we have over 50 million. Actually, we don't have 50 billion products, but we have more than like 500 million product listings. And how do we ensure that these all items will be correlated? And as we changes the pricing, or do a lot of real-time updates, how this inventory as well as the pricing get updated on real time, and then we'll be able to control and create more of the rollback products and give promotions during our holidays. So that is one of the key items for us for the shopping graph integrations. We also wanted to have more of the merchant control in terms of pre-season, post-season, and in-season management, to ensure like that we have the best of the great items in the aisle at the right times, and when customers are requiring for. And we are also thinking about more of goal and plan-driven shopping. That's why like isn't flourish a lot. And how the users and agents, they will be able to orchestrate and discover and create a bundle. And if some items are not available, how can we substitute those items and purchase like recurringly, right? So in the repeated interval. So that is where like universal commerce protocol is really helping us out, and we are experimenting right now. So this is something will be coming pretty soon to our market. So what are the agentic frameworks we are using in retail? So we are using we have a lot of use cases, right? Some of the use cases are more of solo, where like it's looks very simpler, towards like collaborative, like little bit complex, and going towards more of the complex architecture. So for our simple architectures, we use LangChain. So LangChain is pretty popular, and it's more of experimental, like which enables teams to prototype something very small and deploy into production. And little bit of complex, we use LangGraph, and now we have shopping graph from UCP. So that's another things we are also using from Google. And we also use Autogen. We are like more of a powerhouse from Microsoft. So we use Microsoft as well as a GCP platform. So from GCP we use ADK platforms, and in some teams they are using 3AI as well. But we wanted to holistically see, you can create your agents like using any kind of platforms. Then we have our standardized MCP layers as well as A2A, where you can go and collaborate to each of these agents which has been deployed into production. As I mentioned, we are a powerhouse of GCP. So we use Gemini and Vertex AI. So this has been powering our retail industries. So we use Gemini 2.5 Pro, which has advanced reasoning capabilities. We use Gemini 2.5 Plus, which has efficient model. We invest a lot on the Vertex AI, so which is helping us to build the AI agents, and we also use the agent studio as well. And we use A2A protocol like for communicating between the agents. Give me a second. So as I was talking about, like how you're using A2A extensively. So in the left hand side you can see, so let's say you have a complex agentic system where you have 5 or 6 agents which has been communicating with each other. So maybe in this example, let's keep 2 agents, and you have your own local agents, and which has been deployed into production. Then under the hood, like sometimes you use Vertex AI, sometimes you just use your core large language model and use your own agent framework. Then the primary thing is that how do you communicate between these agents, which has been deployed across like it's a pricing, inventory, fulfillment. And one of the things we what we are looking for is that how these agents will be able to find the right retail capabilities and support for faster lookup. So that is where A2A is helping us out. And A2A like collaborate using the standard JSON cards to declare these capabilities, and then they can collaborate and advertise their own capabilities. And it's like you advertise your skills through your resume. So this way, like they advertise, and then they communicate with each other and try to use the functionalities what has been designed specifically for that agent. So as we're talking about like A2A, we also use extensive MCP. This is something I didn't put in the slide because we have a very limited time. But we, in terms of MCP, we all know that MCP is USBCC for all this agent. They can plug and play. We have a lot of, I think, more than 5,000 MCP servers, and we have our own MCP registry as well. Like we follow religiously about our security and authentication and authorizations for RBAC and ABAC. And we have our registry has been like there for a decade in terms of SR, and that is where we are trying to utilize for like putting our MCP registry. So now, as we talk about MCP and A2A, so one of the things what we are trying to see in our traditional approach, as I was talking about how these items come from the supplier producing those items for the merchants. Like merchants are like category CEOs, and they're the ones they order those items to the supplier, and those items they come to the DCs, FCs, or like MCs, and from there those items they get through the Walmart's transportation system into the store. So and then the process of Spark drivers and the regular customers, right, going to the store, buying these items and bringing it back to your home. So or like delivering those items to your fridge through in-home delivery or through drone or hub and spoke. So this process is very complex. And in traditional way, we used to follow the BPNM, and now with the agentic architecture, we try to utilize some of the functionalities. We have been heavily focusing on the Camunda, IVATX, and a lot of complex BPM architecture. Now we wanted to converge those into more of agentic orchestrations, where using those models, how can we be able to like inject the AI agents instead of the human decisions to improve our optimized workflows. And that is where like we wanted to collaborate with robots, AI agents, and peoples with a unified business model to improve our continuous insight, and which can be more adaptable, optimized, and resilient. So when you want to evaluate our like, old workflows, so one of the things what we wanted to focus on, the first thing is the model. So how the model is rock solid, and using the model like from large language model as well. And now like in terms of implementations, how can we use the RAF, human in the loop, and API event, and operate them more of a control specific instances as they progress to the process. Because once we roll it out to production, the goal is to make sure that the number of issues are quite zero. So if the error rate is even 0.001%, let's say changing a price through the digital inks which has been deployed across Walmart stores could cost like maybe 100 to 200 million. So that kind of scales we are looking for. So we cannot like tolerate even 0.001% of error rates, and that's why like wanted to be very proactive in terms of monitoring, going inside into our historical instances execution, try to see what's the real time execution happens. And as we monitor, we also wanted to optimize and improve our KPIs to ensure that this agentic process is pretty solid, and it doesn't have any kind of issues, and try to take out all the bottlenecks for the issues detections. So one of the things that crucial things what we follow is in terms of agentic orchestrations, we wanted to like keep a lot of signals. You can see here like some of the processes are green, some of the processes are red, and you can see we have an entire like session of all the agentic process what's happening as the process gets started from beginning to the end. So you'll be able to visualize and see where exactly the agents are getting failed, and where the retrieval like we have to retry, and where exactly it's getting successful. So those kind of execution steps you'll be able to see in the panel, and based upon that you'll be able to take a right and cognitive decision of what exactly it's been stopped for the operation, or like if the entire like agentic loop is successful. So agent monitoring is a very crucial thing for us. So in our process dashboard, you'll be able to see as the executions are going through, you'll be able to see statistically like which the process has been consumed successfully, how much time it's been taking, and how is the error rate, and how much token it's getting consumed, and how much is the expensive process operations, and how do you tune the process. Everything you'll be able to see in our dashboard. So this is one thing about the agentic orchestration monitoring and optimizing our BPM. So now we also take very seriously in terms of optimizing our AI models as well as agentic architecture. So one of the things what we think about like now as systems are getting evolved towards agentic, as so do like all the large language model. So a few years ago, large language model was like more of fancy items, like people wanted to try it out, but it also cost a lot of energy, as well as as well as like a lot of context will also get diluted. So that is where like when we started like putting our model into, let's say, trucks. So we have more than like 15,000 trucks and 35,000 drivers, and as we are like rolling out this model into our like in transit transportation systems and using the private Wi-Fi network. So our goal was how can we create a small language model instead of the large language model, which cannot fit in the truck, and it cannot get enabled through the power what truck produces. And how do you optimize in terms of the size and even the cost? And that is where like we started tending towards the small language model, and we are focused towards like 3 to 8 billion parameter models, which has been like now offer delivering better results for our Walmart transportation systems, as well as, let's say, for pharmacies you wanted to try the glasses. Maybe you go to like Walmart Optics to try for some AR and VR glasses, or like going towards the pharmacy to see what kind of actions is going to get allotted for you. So those kind of small use cases we started deploying with a small language model (SML), as well as very specific towards that core functionalities. And in terms of the precision strategies, we implement int 8 and int 4 quantizations with EP16 VF16 mixed precision. So this has been reduces our memory footprint by 50. I think it has been going beyond 75% as well. So we also use our memory optimizations. We use flash attention and page attentions to achieve lower memory and faster decoding. Give me a second. So in terms of the retail agentic architecture, so we talk about the large language model, how can we go towards the small language models. Now we also try to optimize, because agentic systems has been deployed into Walmart's architecture over 3 years maybe, and now as we are trying to optimize more and more and making it more scalable for across all the functionalities at Walmart. So usually what we are thinking about, as I was talking about creating solo agent towards reflective agent and collaborative agents. So one of the things what we are seeing is if it's a solo agent, how can we prioritize to 3 billion parameter first, and as we are escalating something let's say something very severe, let's say we are changing the price, and that's more of a very sensitive task. And how can we escalate that to more domain specialists? So from generalized towards domain specialist, exactly when the requirement is there, or in terms of the uncertainty arises. So in terms of state hyphen, so we maintained a structured blackboard memory with JSON IDs and pool histories and reference passings. We use a lot of backstepping. We parallelized our independent agents, and we create micro batches for our call efficiency. So this is more towards agentic architecture. But doing this agentic architecture, we also optimize our MCP servers. We also optimize our A2A, which I'm going to talk now. So in terms of the retrieval and MCP server optimizations, the first thing we try to do is chunk optimizations. We use tight 200 to 400 tokens with recall and rerun pipelines. We try to feed only the top 3 results to minimize our context pollutions and process overhead. So mostly we use concurrency controls. We use inline write request with queues, and we use rate limiting, circuit breakers, and we apply back pressure and load settings. As we see the demand exceeds our safe capacity, we try to control the number of requests, because the Walmart has more than 350 million customers, and that's why we wanted to see how do we ensure that in terms of demand, how cannot we go beyond the bottleneck and rate limit our systems. And that's why we wanted to optimize our performance patterns. We deploy time modes, we deploy retries, circuit breakers. As the request comes in, lot of times it's about shared memory or shared database or shared cloud. So we say the low price request, which are not that much of sensitive when our queue depth exceeds 75% of our capacity. So in terms of caching strategies, we memorize our context by tools, and our version has we use request coalescings for identical calls, and we also use blob storage and serve large data by URL reference. So using all these strategies, what we talk about, optimizing the model and optimizing the agentic architecture and MCP as well as A2A optimizations. So we have drastically saw our production impact. So we have seen 75% of cost reductions, which has been gone beyond 0.2 to 0.005 per query through quantized 7 billion models. And we have seen our latency has drastically been improved. 7% of that, so from 5 seconds towards 1.5 seconds, and going towards less than even 1 second. That's kind of great improvement, I would say, using parallelizations, batching, and stream optimizations. In terms of throughput boost, we have seen the systems have been quite able to take more number of queries from 1K to 3K queries per hour using the dynamic patches and intelligent caches. So yeah, I think that's all for today. And maybe I'll take a second just to talk a little bit about our team. So our team is it's growing. So now, like every team is looking for the AI employees. And similarly, we used to have staff engineers. Now things has been changes to staff AI engineer. So do we like we invest a lot in terms of the AI industry and the new AI talents. And we have a lot of positions on AI engineering, data science, product management, and AI operation. So in case like you wanted to contribute and make an impact towards towards a system like Walmart, who is more than 1 trillion company, and help yourself, your family, and friends to save money and live better. So you are always welcome. Go to careers.walmart.com and you can use my referral code or my name Ashwini, last name Atibudi, to apply for my referral. So that way, like once you apply, we'll get a notification from the HR, and I can initiate the conversation with the HR, like to help you out. But try to find out the optimized one if you're really interested. Don't try to spam to put 3 or 4 positions. Try to see if you can apply for 1 or 2 positions. So yeah, and along with that, we also run kind of a hands-on workshop. It's not workshop; it's kind of cohort. So we learn from each other. So we have a kind of team of 300 to 400 developers. If you want to be part of that discussion, I'll be happy to share the WhatsApp group. So please, if you're really interested to join, so please join, and we can collaborate and learn from each other. That's all for today, and thank you for your time, for hearing my presentation, and let's discuss for the future opportunities. And if you have any kind of questions, I'll be happy to elaborate on any topics. And over to
Thank
you.
you, Swani. We appreciate you. This was an excellent keynote, and thank you so much for joining us. Unfortunately, we're out of time for this session, so I'd like to thank everyone for joining us today. This session, along with all of today's content, will be available on demand following the event. Now, our next session will begin in a few minutes, which will be a thought leadership titled Marketplace Thought Leadership and Demo, From Alert to Answer, AI-Driven Root Cause Analysis for On-Premises Infrastructure. Please remain on the stage, and the next session will begin automatically. Look forward to seeing you there. Sweeney, thank you so much. This was wonderful.
Thank you, Michael.